Kia ora. The intersection of a line and a hyperbola. Example, find the point or points of intersection of A, the line y equals 2x minus 1, and B, the hyperbola xy equals 15. Now, as with the other questions, I recommend a quick sketch of the line and the hyperbola. If you haven't sketched a hyperbola before, then I would rearrange that equation for y equals 15 over x and just plot some points in and see what you get. When you do that, you should find that it looks like this. So the green line, where there is an asymptote line on the y-axis and the x-axis, so it doesn't exist along those lines. And the graph of y equals 2x minus 1 is on there, so the gradient is 2, the x-axis, the y-axis intercept is -1. So from having a look at that sketch, we should have 2 points of intersection. So let's look at solving that now to see what they are. Okay, so here's our two equations, y equals 2x minus 1 and xy equals 15. So what we want to do here, label them equations 1 and equations 2. And then we would want to look to substitute equation 1 inside equation 2. So if we do that, we're going to end up with, instead of writing y, I'm going to write 2x minus 1 in brackets, and that equals 15. Next, I'll look to expand out the brackets. So x times by 2x gives me 2x squared. X times by -1 gives me -x, and that equals 15. I'd then look to move my terms over to the left-hand side and set it equal to 0. So positive 15 becomes -15. And then I'd look to think of how I can factorise this. So the fact that there's a 2x squared, I'd put 2x here and x here. And then I'm looking at the end number of -15. So what possible options have I got that multiply together to give -15? So I've got 1 times by 15, with one of them being negative and the other being positive, or 3 times 5, with one being negative or the other being negative. Okay, so then if I look to work out which combination would work well for this situation, I would see that I'll try putting in -5 into here and 3 here. So that would give me 2x squared plus 6x minus 5. Then I'd think, no, that's not going to work. I'll make this one negative and that positive. Try again. 2x squared minus 6x plus 5x is -x, and then that would give me the -15. So I've got my two factors here. Either this one equals 0 or this one equals 0. If the first one equals 0, we've got 2x plus 5 equals 0. Solving that, so moving the 5 across, -5. So 2x equals -5. That means x equals opposite of times 2, divide by 2, -5 over 2. Or, looking at the second factor, x minus 3 equals 0. So x equals 3. To get their corresponding y values, we could substitute into equation 1. So at x equals -5 over 2, substituting into 1, we would get y is equal to two times -5 over 2 minus 1. So 2 divided by 2, so you've got -5 minus 1, so that's -6. So that's our first coordinate, -5, 2, -5 over 2, -6. Let's put that down there. And then when x equals 3, substituting that in to y equals 2x minus 1, 2 times 3 minus 1, so that's 6 minus 1 is 5, so then we've got our second coordinate, which would be at 3, 5. And if you have a look at the graph, you should find that those points coincide nicely. And sure enough, when we look at the graph, you can see that is consistent with the points that we've just solved. And so what I want you to do now is to go to page 475 and look at exercise 29.03, starting with questions 5, 7, 9 onwards, and see how you go.